With this problem, we're going to explore how to compare two data sets and their mean absolute deviations. You can find the mean absolute deviation for a single data set, but when you have a second data set with similar data and you're able to compare two different mean absolute deviations, it makes it a little more powerful. The lower the mean absolute deviation, the less variability there will be in a data set. The higher the mean absolute deviation, the more variability there will be in a data set. So what I have is we have data sets that both have an average or mean age of 12. So you can think about a group of classmates working together, and you can figure out how old they are on average. With this data set, there are 6 people involved, and in the second data set, there are also 6 people involved, and each of the numbers represents what their age is. First step in calculating the mean absolute deviation is we're going to figure out what the average of these data sets are. So we need to first add all these numbers together. And when you add 12 together 6 times, you're going to get 72. That 72 then will be divided by the total number of numbers in the data set. So we get 72 when we find the total, and then we will divide that by 6, and most of you are probably thinking it's a little silly that I did that, because you can tell that the average is going to be 12. But we added it together, got 72, divided it by 6 because that's how many numbers there are there, so we have an average here of 12. So I'll just write that over there. So the mean is 12. Okay, now the next step to find the mean absolute deviation is we need to see how much each of these individual data points deviate from the average, and in this case the average is 12. So the distance that each of these is from the average is calculated by subtracting. So I subtract the 12 minus the 12 and I get 0. So what you can see is there's not much variability or deviation in this data set. So we have 1, 2, 3, 4, 5, 6, just like we had 6 up here. Each one of them is 0 years away from the average. So when I add all those together, I get 0. And then I divide that by how many pieces of data is in the data set, and it's 6, and that is 0. So our mean absolute deviation is going to be 0. Okay? So just talking through those steps again, the first thing is you calculate the overall average of the data set, which we added them together. We got 72 divided by 6, and that equaled 12. So we had our average or mean right there. Then we need to figure out what the average distance each data point is away from the average. So what we do is we subtract the average minus each data point, and in this case they each were 0. You then calculate the average of that, and that will give you your mean absolute deviation. Okay? So we're going to do it again down here. Now if I just asked you based on looking at these two data sets, most likely you're going to be able to tell me that this second one is going to have a higher mean absolute deviation, just because of the fact that yes, we have an average of 12, but we have these students that would be 10 years old and these students that would be 14 years old. Again, first step, we calculate the mean. So you're going to add each of these values together. So you end up with the 14s added together plus the 10s added together, and you're going to get 72. And you would divide that by 6 just like we did before, and you're again going to get 12. So our average, which is the first step in calculating the mean absolute deviation, is once again going to be 12. Okay? Our next step is we need to figure out how far each of these points is away from the mean. Again, the way we do that is we take the 12 and we subtract 10. So, for this one, we're 2 away. For this one, same thing. 12 minus 10, we're 2 away. 12 minus 10, 2 away. Now we're going to flip it and we're going to do 14 minus 12. But you'll find that you're still 2 away. 14 minus 12, 2 away. And 14 minus 12, 2 away. Now, we find the average of those distances of each data set away from the average. And in this case, when we add those together, 2, 4, 6, 8, 10, and 12, we divide by the total number of numbers in the data set, and we get a mean absolute deviation here of 2. So the power of that number is I could give you just this value, and I could give you just this value, and you would be able to tell me that on average the data set in the second data set, or the mean absolute deviation in the second data set, has a higher variability than the mean absolute deviation in this one. The higher this number, the more variable the data. So the higher this number, the more spread out the data is. The more gaps you may find in the data. With a mean absolute deviation of 0, you're going to know that every single data point's the same, but you'll also know that that data is clustered. That data is less variable than the other data set. Once again, take a look at this video. If you're confused by anything, take a look at the video a second time. And obviously you can email either me or Mr. Barone.